All right, honors pre-calc. We are going to start chapter 8 today, and we're actually going to be starting with section 8.2 instead of section 8.1. We'll come back to 8.1, but we're going to start with 8.2. So some of this is going to look familiar to you because I'm sure you've had it on pre-ACT or SAT, or if you've taken the ACT, you've probably already seen questions like this. So this is the typical, here's a list of terms, find the pattern, and then what would be the next term or the next three terms or something like that. Sometimes the patterns can be complicated and sometimes they're really simple. And we're going to start with one of the simplest patterns, and that's called arithmetic. And we're going to start by talking about a sequence. Sequences are just lists of terms. So this example right here is a sequence. You're used to seeing that, a list. What we're going to talk more about today is some more notation and how to write an equation relatively easily. And then not only finding the next term, but maybe finding the 100th term or the 1,000,000th term. And rather than listing a million terms out, there's a faster way to do it. So let's just get started. A sub 1, that denotes the first term. A sub 2 stands for the second term. A sub n can be whatever I want it to be. So my nth term could be 20, and then I would have an a sub 20. If your list has an ending, like if there was not a dot 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 at the end of here, if it just ended at 11, that would be a finite sequence. But since I have dot dot dots, that means it's an infinite sequence. So arithmetic, just look at the pattern here. What is the pattern? It looks like we are adding 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. That's a nice and easy pattern. That is an example of arithmetic, because arithmetic means you are adding the same number each time. So if you notice that pattern, you're adding the same number each time, you are dealing with an arithmetic sequence, which is a good thing because you're going to have nice formulas to use and you won't have to think as hard. One of the major things you're going to need to find is what's called a common difference. We use a D to signify that. So that's the number that you are adding each time. Now you could be adding a positive number or you could be adding a negative number, but it's whatever you're adding each time. So let's look at a couple of these examples. So right here, this first one, what are you adding each time? So it looks like we're adding 4 each time. So that is an arithmetic sequence, and our common difference is 4. Over here, what are you adding each time? Well, you notice the numbers are getting smaller, so that means we must be adding a negative. So 2 plus negative what? 2 plus negative 5 would make a negative 3. Plus negative 5 more would make a negative 8. Plus a negative 5 more would be a negative 13. And yes, you can think of it as subtracting 5. But just realize that your common difference would be a negative number. So bottom line, if you're subtracting each time the same amount, D would be negative. All right, last example over here. Sometimes it gets a little trickier when you're dealing with fractions, trying to do mental math to figure out what you're adding each time to get those fractions. If you don't want to have to sit there and think too much, what you could do is you could find the difference, because that's, after all, that's what this is, a common difference. So I could just do 5/4 minus 1, and when I do that, that's the same as 5/4 minus 4/4, so that's 1/4. And then I could see if that common difference is the same between those two. So is 3/2 minus 5/4 the same thing? So 3/2 minus 5/4, yep, you get 1/4. And then I could find the common difference between those two. Is 7/4 minus 3/2 That's like 7/4 minus 6/4. Yeah, you get 1/4. So the common difference here is 1/4. Okay, so you're going to have to be able to do that, identify the common difference. You're also going to have to be able to identify whether or not something is arithmetic, because not everything is. We like it when it is, though. So you're just looking, are you adding the same thing each time? So in A, are we adding the same thing each time? Looks like we are. It looks like we're adding 11 each time. So yes, that is arithmetic. How about B? Looks like here we're adding 4, but here we're adding a 6 to get to 12. 12, we would have to add an 8 to get to 20. Nope, this is not arithmetic because we're not adding the same thing each time. Let's see, if I wrote this out, this would be 1, 4, 9, 16. Am I adding the same thing each time here? Let's see, 1 plus 3 would make a 4, but 4 plus 5 makes 9. Nope, we're not adding the same thing each time. So this is not arithmetic. Last one, are we adding the same thing each time? It looks like we are adding a -7 each time, so yes, this is arithmetic. So just being able to identify whether or not it's arithmetic. Now, if you know it's arithmetic, good news, you got a formula. So here is your formula. This is only going to be used if it's arithmetic. So only if your list of numbers is being added the same amount each time. A sub 1 is your first term. D is that common difference. As long as you know those two things, you got your formula. So if I'm looking at this list of numbers, it looks like we are adding 3 each time. So that's my common difference. My first term is a 2. So I have enough information, I can write my formula. So my first term is a 2, my common difference is a 3, and then I multiply that by the quantity n minus 1, and there's my equation. I can leave it just like that. Now, a lot of you are going to be tempted to distribute the 3 through. So here's what it would look like if you distribute the 3 through, and then you'll notice that, yeah, you can combine some like terms. So you could say that this is 3n minus 1. That formula is also fine. And what you might notice is this kind of looks like mx plus b. It's linear. And that ties into the fact that you are adding the same thing each time. So, for example, if you were going to plot this on a graph, and we'll say that 1 represents your first term, 2 represents your second term, third term, fourth term, fifth term, sixth term. Okay, and then maybe we make our y-axis the value of those terms. Let me add a couple more. All right, so for example, our first term was a 2. Our second term was a 5. Our third term was an 8. Our fourth term would be an 11. So you're going to see that this is a line because it's increasing by the same amount each time. So that's a tie-in. Anytime you have an arithmetic sequence, it's a linear pattern. Now, I would say leave your equation like the purple one because I can pick out important information a lot easier. I can pick out 2 as the first term and that my common difference is 3 really easily this way. Just leave it like the purple. Okay? So if I have a list of numbers, I can come up with an equation that represents that list. The reason why you would want an equation is if I want a specific term, like let's say I want the 100th term, sure, I could list out all of these until I find the 100th term, but who wants to do that? If I want the 100th term, I can just plug in a 100 for n. And that's so much faster. So in my formula, if I want the 100th term, I'll have 2 plus 3 times 100 minus 1. All right, we'll type that in your calculator. 2 plus 3 times 99. And you're going to get 299. That would be the 100th term. So I can find any term I want super fast if I know my formula. That's why it's good to know. So arithmetic is nice because you got a nice formula. All right, so here's another one. We'll do this really, really fast. Find a formula for the nth term and write the first 4 terms. All right, well, I'm given the first term. I'm given the common difference. Just plug it right on in. A sub n is going to equal 15 plus 4 times n minus 1. There's my formula. I can use this formula to find like the second term. I could plug a 2 in for n to find the second term. I could plug a 3 in for n to find the third term. Sure, I can do that. Or I'm given the first term. I know the common difference is 4, so that just means I'm adding 4 each time. So the next number would be 19. Then add 4 to that. We get 23. Then add 4 to that. You get 27. Well, there's my first 4 terms, so I'm done. But I could use the formula too if I wanted. Okay. This problem, we're going to find a formula. And I'm giving you the first term, which is great. But I'm giving you the 5th term. I did not give you the common difference. So that is what you need to figure out. So here's the scenario. The first term is a -4. I don't know the second term or the third term or the 4th term, but I do know the 5th term is a 16. That's what I got so far. I'm trying to figure out what is the common difference. What do I need to add, and then add, and then add, and then add again to get a 16? So how many times are you having to add something? Once, twice, 3 times, 4 times. So I have to span from -4 to 16, and I have to make that jump evenly divisible in 4 jumps. So here's one way to do it. The distance from -4 to 16 is 20. And I have to make that distance in 4 jumps. 20 divided by 4 is 5. So that means that that's my common difference. -4 plus 5 would be 1. Plus 5 more is 6. Plus 5 more is 11. Plus 5 more is 16. So that common difference is 5. That's one way to do it, kind of just figuring out how many jumps you have to make. Another way to do it is to remember that if it's arithmetic, that means that it's linear. And the common difference is similar to a slope. Like if we go back to that original picture, that slope is going up 3 over 1, up 3 over 1. My slope was 3. That's the common difference. So use the idea of slope. Okay, so here, when you plug a 1 into the formula, you get a -4. So think of it as a point. Here, when you plug a 5 into the formula, you get a 16. Think of that as a second point. Well, if you find the slope, it would be 16 minus negative 4 over 5 minus 1. And you're going to get that same idea of 20 divided by 4, which is 5. I don't care how you figure it out. Those are just a couple ways to do it. But bottom line is we need to know D. Now that we know our first term and our common difference, we can write our formula. So it'll be negative 4 plus 5 times the quantity n minus 1. That's our formula, and that's all I was instructed to do for this problem. Okay, this one, again, similar, but I'm giving you different information. So in the last problem, I gave you the first term, but we had to find the common difference. Here, I'm not giving you either. So I'm giving you the 6th term and the 15th term, and I want you to find the 24th term. So if I was to kind of write this out, first term, second term, third term, fourth term, fifth term, sixth term is 20. 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th term is a 65. That's what I got so far. Now, I need to figure out what the 24th term is. If I can find the pattern, if I can figure out how much I'm adding each time, I could certainly just keep adding and adding and adding until I find the 24th term, but that might take a while. I could do the thing where I figure out what is the span from 20 to 65 and how many jumps do I need to make. But in all honesty, I just think it's faster to use that idea of slope. So I'm going to take 65 minus 20 and divide it by 15 minus 6. Now, if that was confusing, like why did I choose those numbers that way? Remember, this is technically like a point. If I plug in a 6, I get a 20. If I plug in a 15, I get a 65. I'm just using my slope formula, y2 minus y1 over x2 minus x1. That's the fastest way I like to use to find that common difference. So this will be 45 divided by 9, which is 5. My common difference is 5. If I'm going to write a formula, I need to know my first term. So I need to figure out what this first term is. One way to do that is I can just backtrack. Now that I know my common difference is 5, I'm adding 5 each time, so these numbers are increasing. So that means my first term has to be smaller. I add 5, I get a bigger number. I add 5, I get a bigger number. So if I'm backtracking, I have to subtract 5. So this would be 15, 10, 5. Remember, if I'm subtracting 5, I would have a 0, subtracting 5 again. That must mean that my first term is a negative 5. So I could write my formula now. I could say a sub 1 plus d times n minus 1. The only reason why I would maybe want to write that formula is so that I don't have to keep adding 5 to figure out what the 24th term is. I can find the 24th term just by plugging in at 24. Okay, so if I plug a 24 in and I type that in my calculator, I'm going to get 110. So that means my 24th term is 110. Now, for all these problems, there's a long way to do it and there's a shorter way to do it. It's to your benefit to learn the shorter way just because it makes things easier and faster. But you certainly can list out, 24 blank spots, keep adding 5 until you find the 24th term. I just think this is faster using the formula. All right, let's try this one. Okay, so I'm not given the first term. I'm given the third term, which is 19. 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th. The 11th term is negative 5. I'm supposed to find the 20th term. So I need to figure out, and I'm told this is arithmetic, so I know there's going to be a common difference. I got to figure out what that common difference is. I know that it's going to be negative because my numbers are decreasing. So I'm going to use that idea of slope again. So I'm going to do -5 minus 19 divided by 11 minus 3. So I'm going to get -24 over 8, which is a -3. So my common difference is a -3. So like 19, I would subtract 3 from that and I would get 16. And I would subtract 3 from that and I would get 13 and 10 and 7 and 4, 1, -2, -5. That seems to work, right? But what I really want is the first term. So I'm going to add 3 to go backwards. So if I add 3, I'm going to get a 22 and then a 25. So my first term's a 25. My common difference is a -3. I want to find the 20th term. Instead of me continuing subtracting 3, which I could do, I'm going to use my formula instead. So my first term, plus d, but d is a negative, so I'm subtracting. Here's the formula in case you've forgotten it. Okay, it's just that d is a negative, so instead of adding a negative, I'm subtracting. And if I want to find the 20th term, I'm just going to plug a 20 into my formula for n. Type that in my calculator. The 20th term will be a -32. Okay? So, just as a little recap, arithmetic means that you are adding the same thing each time. That's what the D is, the common difference. If you know something is arithmetic, here's your formula. You can use that formula to find any term you want. Remember, this is linear. If it's arithmetic, it's linear. So you can use that idea of slope to find the common difference if you want. Or you can find it other ways. I don't care which way you go about solving these. I just think it's to your benefit to figure out the fastest way possible. So that is it for today. We'll continue with this section tomorrow. Have a good day.